Today, we're going to pull back the curtain on a little piece of everyday magic. You know, something you probably use dozens of times a day without even thinking about it. I mean, really, have you ever stopped to think about it? You start typing a few letters, and boom, your phone is basically finishing your thoughts for you. So is it psychic? Nope. The real answer is actually way, way cooler. You've seen this a million times, right? You type app, and this list of suggestions just appears out of nowhere. It feels instant, like it's reading your mind. But how on earth does it search through a massive dictionary of thousands, maybe millions of words that fast? Well, the secret sauce behind all that speed and efficiency is a special kind of data structure called a trie. It's the unsung hero of your keyboard, and we're going to break down exactly how this amazing little thing works. Okay, so let's get into it. A tree, and you pronounce it just like you'd try something new, is also called a prefix tree. And honestly, that name gives you a huge hint about its superpower. Just think of it like a family tree, but for words, where every single node is just one character. You know, the best way to get it is to just build one together. Let's start with a super simple word, cat. Our trie always starts with an empty root, and the very first letter, C, becomes its first child. Pretty simple so far, right? Okay, so from that C node, we just create a new branch for A, and then from the A node, another branch for T. And there you have it. We've created a path, C-A-T, that spells our word, and this is important. We'll put a little marker on that T to say, hey, this is the end of a real word. Now, this is where the magic really starts to happen. What if we want to add the word car? Well, we don't start over. We just follow the path we already built for C and A, and only then do we create a brand new branch for the letter R. We're literally reusing the common prefix. How smart is that? And it's the exact same idea for the word cap. We just follow that CA path we already have and just tack on a new branch for P. Are you seeing the pattern here? All the words that start with ca are all neatly tucked away under the same branch. This is the whole foundation of how prefix searching works. So, the logic for adding any word is actually incredibly straightforward. You just walk down the tree one letter at a time. If the path you need is already there, awesome, you just follow it. If not, you create it. And when you get to the end of the word, you just flag that last node to say, this is a complete word. That's it. And what's really cool is that the code to do this is just as simple as the logic we just talked about. It's basically just a loop that goes through each letter of the word, it checks if a branch exists, creates it if it doesn't, and then just hops down to the next level. It's so clean, so direct, and ridiculously efficient. And searching, well, searching is even easier. It's the exact same process as inserting, except this time you're not allowed to create anything new. You just trace the path. If the path breaks at any point, or if you get to the end and that last node isn't marked as a complete word, then you know for sure that word is not in our dictionary. And here we go. This is the big aha moment. When you type app, the system just zips down the tree along the APP path. Once it gets to that final P node, all it has to do is look at all the possible paths that continue from there, like LE for Apple, or all the letters for application, and it just shows you those as suggestions. That's the whole trick. And the speed, it's just mind-blowing. See, if you were searching a normal list of words, you might have to check every single word. With a trie, the search time only depends on how long the word you're typing is, not on how big the entire dictionary is. That's why it feels completely instantaneous. Now, of course, tries aren't the perfect tool for every single job. Their one true superpower is that prefix search. If you compare it to something like a hash map, you can really see the trade-off. Hash maps are usually better with memory, and they're great for checking if an exact word exists. But for autocomplete, yeah, the trie is king. No contest. If you remember just one thing from all of this, let it be this right here. A tree will gobble up a potentially huge amount of memory to store all those little character nodes, but what you get in return is that lightning-fast search speed. It's a classic, beautiful engineering trade-off. And, you know, this powerful idea isn't just hiding in your keyboard. It's the backbone of spell checkers, it helps with dictionary lookups, it's even used in network routers to figure out the fastest way to send data across the internet. It's truly one of the fundamental building blocks of our digital world. So, the next time your phone finishes your sentence, you'll know. It's not magic, it's not psychic, it's just the elegant branching logic of a tree working its magic behind the scenes. It's a great reminder that some of the most seamless experiences we have are powered by incredibly clever and sometimes surprisingly simple ideas. Which makes you wonder, what other invisible structures are shaping your world right